For my next project, I'm going to do a coffee table, a glass-topped coffee table supported by a very beefy ribbon. Now, I've done a lot of ribbons over the years. I invented the technique, probably 10, 12 years ago. But I've never done a big beefy ribbon, something strong enough to support a heavy glass top. So my first challenge, my first decision was what shape ribbon. And there's all kinds of shapes you can make out of half bowls with a 45-degree slope angle. And so I just went to my miter saw. I cut a bunch of compound miters and glued and taped them together, played around with the shapes, and I came up with this shape. It requires 4 bowls or 8 half bowls. Now, for your own project, if you want to do another shape, go ahead and play with half bowls, tape them together, and arrive at, probably a number of other shapes would work. This is what I chose. My glass top is probably going to be square, although I might pick a round top. I haven't decided yet. It won't matter. So with the shape determined, what material? Well, I have some very nice 8/4 babinga. That's going to be my primary wood. And I might accent it with a few little pieces of bird's eye, maybe a little bit of Mikasa ebony. Haven't really decided on the total color scheme yet. We'll work that out as I go along the project. Now, regarding the miter angles, the miter fence and the blade angle, that's a matter of just looking it up in a chart. This chart happens to be in the back of my book, but you can find this information in many places on the internet. I've gone to the column for 16 staves, and I've gone to the row for 45 degrees of slope angle, and there's my 2 magic numbers, the miter angle and the blade angle. The miter angle has to be subtracted from 90 because we're measuring from a different place on our saw equipment. So it's actually about 8 degrees on both of these angles. Having decided on the shape, I need to determine how big the material. Well, I know the thickness. I can calculate the width of the staves because that'll determine the diameter of my bowls. The diameter of the bowls, if you look carefully, determine the height of my top. So a bowl diameter around 16 inches is what I'm going to shoot for. There'll be a thick glass top on top of that to give me another ½ inch of height. Each one of these half bowls, even though they're at an angle, do account for 8 inches each, therefore the 16-inch diameter. Now here's a simple drawing that I've done just to help me visualize the profile or the size of the ribbon. I need to know how long the material, how tall the stave should be. And this will allow me to just visualize that dimension. Those green lines represent the in view or the side view, I guess, of the staves. And by looking at it like this, I can estimate. I'm going to go for about 7 inches and see how that looks. I'll draw some lines there and see how large or small my opening is there at the bottom, just to give me a feel. But I'm pretty sure somewhere around 7 inches is what I'm going to look for. Notice I've drawn this with a 17-inch diameter. I estimate I'm going to lose about a ½ inch off each one of those corners when I round them during the turning. So I'm designing this a little oversized for that reason. Now my opening there at the bottom looks like it'll be somewhere around 5 inches, which that's agreeable with me. I'm going to go proceed with this 7-inch length of material in mind. I've got one more calculation to do. I need to estimate how much wood, how much material do I need to cut 64 staves. I'm doing another little sketch here showing a layout of staves cut from this material, this 7-inch long boards. Now, of course, the width of the boards will have an effect on how much waste I have. There'll be a waste piece at both sides of these staves, but at least this will give me a starting point of an estimation. Doing the math, I've got 2.75 inches at least for each stave, 64 staves. That's over 14 feet of width of 7-inch long board. A lot of material. So with my 7-inch length in mind, I'm rough cutting my material just a little stronger than 7 inches. And I'm also cross cutting some of my Mikasa ebony. I'll cross cut some bird's eye maple and assemble these stripes, if you will, that'll provide material for staves with some other species. You'll see this as it comes together. But I'm making a number of these, which I can also cut staves from. This is just a lamination of ingrain to ingrain, but they'll be brick laid as they get put together as staves, side to side grain. So I'm putting these together. I'll clamp these, leave them clamped overnight. A lot of glue there. Well, it was a bit of work to get all this material milled. I've got every piece a perfect length, a consistent length. The sides really don't matter because these are going to get cut with compound miters. But how to cut them? One choice would be a compound miter saw, a sliding saw, but this is pretty big, beefy material, pretty large. That's not going to be my choice. I'm going to go to the table saw. I'm going to build a customized sled. So what I've built is a sled from MDF. I've got a piece here about 28 inches square, approximately, and on the underside, I've installed 2 rails that slide on my table saw. This is the trickiest part, to get these rails perfectly positioned and dimensioned so the sled will slide smoothly with no side-to-side play. I've also put a very thick layer, actually it's 3 layers of MDF on top of my sled, just to give it some mass and to hold this in together. My next step will be to install the miter, but before I do that, I'll set my blade angle. I'll make a pass so I can see where the kerf is going to be in my sled, and that'll be what I measure from to install my miter fence that'll go back here. So I've adjusted my blade angle at about 8 degrees. I've left about 6 inches of material uncut at the back of the sled. Here's my fence. It's a lamination of 3 layers of MDF so that my blade will stay embedded in the fence at the conclusion of each cut. I've also put a dust trap. I've knocked the corner off that lower edge. It's secured with 2 bolts from the underside. It pivots on one side, and I can go from 0 probably up to about 15 degrees with this. I've got a piece of MDF here that I've cut on my miter saw at 8 degrees. That's going to allow me to set this fence at that 8-degree mark by placing my cutoff board against the kerf. A little tightening here. This will be set up for testing. Now I put a stop on my workbench, which prevents me from cutting all the way through, but it allows me to push the sled so the blade is embedded in the fence there, out of sight, out of harm's way, while I retrieve pieces on the other side of the blade. This allows me to only cut the wood once, no secondary contact with the blade in the pullback operation. Now I can use this left-hand piece as my stop block. I'll put another dust trap on the underside of that before I lock it in position with a clamp. The cutting operation now is just a matter of flipping this material over, butting it up, securing it, and making one cut after another. Cut, flip it over, cut, flip it over. I want 8 of these in order to test my angles. It'll probably take me 2 or 3 attempts to get 8 pieces to form a perfect half cone. So here's my first 8 staves. I'm going to tape them together, roll it up into a cone. I'm going to go over to my disc sander, which has a perfect 90-degree angle between the table and the disc. I'm not sanding this, I just want to use that as a way to measure the accuracy of these fits, these angled cuts. So as I go over there, I've got a nice tight assembly here. Is it straight across? Is it the right slope angle? Well, it's not quite tight there at the top. It's closed too quickly. And my slope angle is off a little bit. It's a little flat. It's not quite steep enough. So I'm going to go back to the table saw. I'm going to adjust my miter fence about the thickness of a pencil line, just a little bit, because there's 32 angles there that'll be affected. After doing a second cut, now I've got a perfect fit against my disc, and my slope angle is very close to that 45. I might be off a half a degree, but that's close enough. Now I can go proceed to cut my good material that's already been prepared. So I'm marking my width here for my first stave. Now the calculation was 3.3 inches, but I've gone almost a tenth longer than that. There'll be some loss as this gets turned. I'm locking my stop block in place, and just to make sure it doesn't slip on me during this operation, I'm securing it with a few beads of CA glue. I just can't afford to have that move on me. Now it's a simple matter of cutting and flipping and cutting and flipping. I need 64 of these staves, 16 for each of my bowls. I'm being very careful. I'm inspecting my fit every time I clamp that in place. It goes actually pretty quickly. Cutting the staves went a lot faster than creating the sled. I've done one more check here of my first 8 staves. I wanted to check the diameter, and it came out just a little over 17 inches, which is ideal. That's exactly what I wanted. It's just cutting and flipping and cutting and flipping. So here's my 64 staves, and I cut a few extra. I've done a very careful inspection. They're all ultra smooth, ready for glue. There's really no need to sand these as I glue them together. As for the gluing and the clamping, I'm going to use a different technique than I've used before on staves, because these are pretty large and I want plenty of pressure on the seams. I'm drilling a precisely located hole at both ends. I'll use a double stop block here, one for the small end, then I'll place this other little stop block in place to precisely drill a hole at the other end. Now these will all get drilled, and then I'll go to my workbench and start to glue them together using threaded rods. Notice this little piece of angled support wood. It's just a cut off a piece of waste wood from when I cut the staves. Here I'm countersinking the hole openings just to give the bent rod a little more room at the corner. Here I'm bending the rod at approximately the same angle as my staves fit together. Now I'll thread the staves onto the rods, put washers and nuts on both sides of these staves. My power drill here with the sanding pad actually is a very effective way to move those nuts along very quickly, as opposed to, twisting them by hand. Plenty of glue in the seam, spreading the glue, making sure I've got both seams, both sides of the seam covered with glue, and then it's just a matter of clamping it with the nuts, tightening up those nuts. This particular one needed a little persuasion to get it perfectly aligned. That's where one of these little quick clamps comes in pretty handy. I'm going to just diagonally apply that, apply a little pressure just to get it to line up a little more perfectly. And then finish off the clamping with these nuts, put it aside, give it 30-40 minutes of drying time. I've got to make sure I don't get any glue on those seams, because that's where there's going to be other seams put together. So I take this one apart and do the same process all over again on this one side. And I'll repeat this process over and over until I've got 16 staves put together in 2 halves of 8 each. With this technique, it's important to dry fit, inspect these seams before you ever put the rods in place. You've got to have nice smooth connecting surfaces on all these seams before you clamp them. Well, my 8 halves are complete. Now it's a matter of getting rid of these steel rods. A little hacksaw work followed by a die grinder to get the steel below the surface of my wood. and then over to the disc sander. I'm putting my glue surface down first. My table is at a perfect 90-degree angle, and just touching this edge so it rests solid, doesn't rock when I sand the glue surfaces here. I want pencil marks on all four corners to disappear. Once they've disappeared, I'm relatively flat. Now I can go try to clamp these together. My technique here is to clamp from a clamp. In other words, I'm putting these big beefy C-clamps in place, which gives me anchor points for the quick clamps. Lots of glue, and I'm putting a spacer maple, about 1/8 of an inch thick piece of maple, in between my seams. I need to know where to cut this back apart later. I don't want to cut it where the steel rods are in place. So one end gets done, flip it over, make sure nothing slips out of place. The same kind of procedure here on this other edge. 4 beefy C-clamps, providing anchor points for my quick clamps. Here's my 4 bowls. Now it's a matter of how to mount them to turn them. I first assembled 2 discs of MDF here. This is about 22 inches in diameter, a 2-layer lamination. I'll get rid of those screws. They were just used to clamp it together. Then I'll put a faceplate on here, turn it over, and I'm going to grab another disc of MDF and screw that to the other side of this. This will become a keeper ring. So I'll first secure it to my plate with 4 beefy screws, number 14 screws, and then go to the lathe and remove the center portion of this to create a keeper ring, a donut that will secure my bowls. Get the outside turned round. I need it to be round because I'm going to measure from there when I center my bowls. Now I'm using a parting tool, a wiggle cut, getting rid of the majority of that wood inside. You've got to measure and figure out how much to remove. I'll undercut this surface at about a 45. This is going to squeeze over my cone. I need that cone to rest flat, so just a little touch up there. Walking a ruler around the edge, getting it perfectly centered, and then getting it secured with the keeper ring. 4 big screws here. Then I can go to the lathe and start to turn this opening. I need to true up the opening. Here I'm just checking the roundness, and it's round enough. But the end grain there is a difficult turning operation. A lot of end grain, so you got to go really slow. I did most of it with just a little diamond pointed scraper. Here's the check to make sure that angle's 90 degrees. Here's a plate of maple. It's been turned on a screw chuck. I've got 45-degree slopes on it. It fits very nicely into this opening. Lots of glue and some pressure from my tailstock. The next thing is just to let this dry for at least a half an hour or more before I can mount a faceplate on it. Now that faceplate needs to be perfectly centered, perfectly flat. The way I do that is I'll just position it with my tailstock, draw a pencil line that will give me a guide as to how big a diameter to turn this very shallow recess. I want to sneak up on a nice snug fit that'll position that faceplate perfectly centered to the bottomless bowl that I need to turn. Now, even though this is ready to turn, I want this to sit overnight. I want that waste block to have a very strong joint before I start to turn on this. Well, like most segmented projects, the turning aspect is minimal compared to the rest of the assembly. But in this project, the turning is very critical that you get precise angles and dimensions and so forth. So far, I've managed to get all my bowls at a 45-degree slope using the 2 squares at the lathe. I've managed to get all the diameters using 2 squares again, checking, and I've got all my diameters at just about 17 inches. I've got all my edges here square. What I have not done yet is work on the inside very much. I've done some rough turning on the inside, but I need to get the inside smooth, obviously, but I also need to get it to a consistent wall thickness and the same wall thickness on all of them. So I'm going to go through my stack of bowls here. I'm going to pick the one that I think will need the smallest wall thickness. I'll finish that one up and use that as my sample, match the other three to that. Here's my technique for doing the wall thickness. First, I've measured it, just under 1.25 inches. I've ripped a little piece of MDF the same thickness and glued it onto a straight